it's a shame that we, as we discussed it before, India doesn't have a certified lab in order
But
to
the guy tomorrow, he said sometimes they do the test with the bucket and water.
Okay.
That's something we can
try
to
do.
Yeah.
What is bucket and water?
Bucket and water test for floating the grains.
Actually,
the straw will float and the grains will go down. So the more grains you have below there, it's not good.
Yeah.
So he said he does that. We can ask him how he does tomorrow. That's something we can replicate in the India house.
Yeah.
That's maybe after the lab. That's maybe the best.
The cup test.
Practical test.
The cup test is also good.
Which test?
Cup test.
Cup.
Yeah, he will talk about it.
We'll discuss this later. But the idea is the KPS test. It's a lab test. It takes a lab analysis. It takes time. It takes money for making it. But it's the ideal
more precise.
The more precise value that we could have. So we can compare silage. For example, when we are testing here in Brazil, for example, when we are testing our machines, we send the machines to the field, collect some samples, send to a lab, and the lab tell us, oh, this silage has a good KPS, this one doesn't have a good KPS. And these results tell us from engineering, oh, this is a good way on developing a new thing, or the machine is looking good in these conditions and not on these conditions. The analysis help our from engineering a lot.
So do it like the Z-shaped blade and the C-shaped blade has something to do with the.
We always send the C120 to the field.
Quantity of blades.
The quantity of blades, the speed.
Technology of the blade.
If the PTO speed lowers or the KPS will change. We have a lot of things because we test a lot. Tomorrow, for example, probably I will not go with you on what's the name of the farm? Rancho Alegre, because probably, at least I would like to go to the field and test what some new things we are doing. So
tomorrow supposedly is the worst rain in the week.
Yeah. Yeah. So that's it. So
let's see.
Let's see. If it's not raining, probably I'll go with you. Let's see. But those lab analyses help us a lot in order to choose the best way on changing the harvester, or because otherwise we always depend on the visual. Oh, this is good. This is not.
Yeah. It's guessing.
It's guessing. It's not.
And I can assure you that most machinery makers, they don't go precise like this. They don't use lab tests. They just guess.
Yeah.
But nowadays in India, people are like everybody is like
4 or 5
asking.
years back, we are trying to go more and more towards scientific processes to improve the machines.
Yeah.
But in India, like people are more asking about the processors, the food processors.
Yeah.
Like
in Brazil as well, they are asking for the kernel processors on the machine.
Yeah.
Because what they are thinking, they are right on thinking that the more the kernel is processed, is destroyed, the more the kernel is processed, the fast it will be absorbed by the animal, and the most will actually will be absorbed by the animals and not going into the feces. But they are right. But you don't need to have a kernel processor or a kernel processor generally. It's the most used name on having a good silage with a kernel processor. So, for example, JF machines, they do not have a kernel processor, but the silage making on JF has height KPSs. So the the starch will be absorbed by the animals. So we have a lot of people. Most of the manufacturers. Oh, I have a kernel processor in my machine.
A roller.
And then my silage will be kernel processed. Not really. Of course, they have the way of making it, but it's not sure that we'll have the kernel processed by the rollers. For example, if I am a contractor and I'm making silage for you, and when you contract me, you're not seeing what I'm making. Okay? Go by Monday on my farm and make my silage for me. Okay. The KPIs from the silage will be low, but you will not see it. You are just trusting me that I have a good machine with a kernel processor, but the result will be not good. Just for an example.
That is only a marketing policy, like.
Certainly there is always a marketing on it, and and of course I understand that most of the silage, the grains are cracked, the visual is good, but visual is one thing and KPS is another. KPS is the scientific have 70% water and 30% matter, I believe. I'm not sure about
A
it.
bit more.
Could
Almost
be
80%.
80%. Okay.
80%?
80% is low water.
80%.
80% is water.
Okay, so if Rafael is right, so we have, if we could make
Remember my biology
a
class.
dry matter of the human body, we would have 20% of dry matter. It's when you remove the water, what remains is the dry matter.
Yeah.
Okay. And why it's the main variable? For having an optimal fermentation, the values of dry matter must be controlled between 30 and 35. It's the most recommended values. So from each farmer, because imagine that the dry matter changes 1% per day, and if you start on 30% dry matter, okay, so we are talking that 30 to 35% are good values, okay, and you are measuring dry matter from day to day, 25, 26, 30%. Let's start the harvest. And the guy, picks up the 120 and starts the harvest, and from 5 days, from Monday to Friday, just an example. So 30% on Monday, 31% Tuesday, and 35% on Friday. If the farmer didn't finish the harvest on Friday, then he will have problems. Because on Saturday the dry matter will not be fixed on 35, it will be on 36.
He need to test daily basis.
Yeah.
When it gets close to the harvesting time, it needs to be testing and especially planting in stages.
Yeah.
So he can have always the dry matter something between 30 and 35%.
So, for example, if he knows that his area is too big, that he cannot harvest in 5 days, then he should have a bigger harvester, or he could have a second harvester in order to finish between the 30 and 35 target values.
Or he plants half in 1 week and the next half in another week.
For example.
So he have time to finish one block first and then the other block.
So maybe the cut size is also important for the dry matter. Like if you will cut on the smaller sizes and the bigger sizes, the chop sizes.
No, the chop size will not change the dry matter. The dry matter it's a composition of the corn tree. Let's say the corn
Plant.
the plant. Okay, so it doesn't depend on the chop size.
I think what he's asking is the chop size.
The GF harvester have different chop sizes.
Yeah.
What is the reason behind that?
If it's drier, then generally you will decrease a little bit the chop size
Yeah.
for getting better kernel cracking.
For getting kernel cracker, but this is not related to
No,
dry
no,
matter.
yes, of course, it will not change the dry matter, but as you harvest a drier maize, then we generally suggest to decrease the chop size.
Like
Yeah.
that means
A
if
little
the time period is increased, like the if you harvest on 75 days, now it is 90 days, then you can chop on the smaller particle size.
No. There are different things. The dry matter, it's a variable that changes from day to day, and the ideal is to start from 30% and finish your harvest until 35%, let's say. If your silage, it's too dry, I mean more than 35% dry matter, I would recommend to decrease the chop size, but I would recommend on doing it in order to get a better kernel processor, in order to get a better packing later in the silo, but it will not fix the digestibility, for example. So I will not fix the best condition of 35%. So it's just how can I say it?
It's better that you plan better
Yeah.
than just letting, JF machines are good because they have more chop sizes and they can chop very fine in a case that the maize starts to get too dry.
Yeah.
But we don't want to let it too dry.
Yeah.
It's better that you plan, either planting in blocks, in stages, or having bigger machine, or having two machines.
Yeah.
Than leaving it to dry and but of course it's an argument that he can use.
Mhm.
Okay, if your maize is too dry, we have smaller chop sizes that you can use, because then it's better
Yeah.
when it's too dry, but you don't want to let it too dry. Even if you chop smaller, you might have problems
Yeah.
when it's too dry.
Yeah. These are the reasons. If the corn is have a lot of moisture, if it has a lot of water, you will have low starch. The kernel is not yet developed, and because of this, you will have low starch compared to an optimal dry matter between 30 and 35%. You will have height losses on the silo, because when you're packing it has a lot of water. When you're packing with the tractors, the water will go out, and the water will carry a lot of nutrients that would be important for the cow later. And certainly you'll have a bad fermentation, because if you have a lot of water, you don't have the optimal environment for the bacteria to grow. Okay. But if you have a high dry matter, you'll have aerobic deterioration, you'll have low digestibility of 5% of starch. You'll see it later. So it's drier. The drier the silage is, the low digestibility it will be, and you'll have a difficult packing as well. It's much more difficult on getting the oxygen out of the silo with a high dry matter, because the tractor is pushing, it's packing the forage in the silo, but it's too fluffy. It's difficult to pack. Okay, and the more oxygen that you have, the bigger losses you will have in the future.
But in India, like people are not checking the dry matter; they just cut and pack. So they don't care about the things now. Maybe later on.
They should take care of it. It's the main variable.
You mean the dry matter is the main thing for the silage?
It's the main thing.
Is the main thing.
It's more important than the machine. For you have an idea, it's more important for the machine than the machine. I would prefer to harvest in the optimum dry matter target using a bad machine instead of having the best machine in the market, JF in this case, and harvesting in the wrong dry matter target.
Okay.
Okay. The crude protein. So the recommended values that I talked to you earlier, between 8 and 9%. So it's related to the amount of nitrogen that you have in the silage. So it decreases if there is poor fertilization, but if the values are too high, above 10%, probably you will have a contamination from Clostridium bacteria inside the silo because of the reasons.
What are the reasons of bacteria? Like you told me that before 30 days we should stop the fertilization.
Yeah.
With manure.
With manure.
Manure. Maybe other fertilization, yes, but with manure.
With manure means like
Leave 30 days, at least 30
before
days.
30 days.
More than 30 days between the spread and the harvest. Okay.
Otherwise,
that is the main reason for the bacteria. That is the main reason for the bacteria in silage.
Yeah, if
bad
you,
bacteria.
Bad bacteria.
Bad bacteria.
Yeah, Clostridium bacteria.
Okay. And what about the aflatoxin?
Aflatoxin. We need.
I need to start
Arisu
with
hasn't heard too much about this yet.
Yeah.
Okay.
But that's something.
In Brazil, it's not much common.
I've never
There,
heard
there
that.
might be, but maybe it's not a big thing. I think
Could be.
it's something that people heard, or in India, we need to get more used to it.
In India, people are too much afraid about aflatoxin. It will come in the silage, it will come in the milk. Like some of our people don't make silage, they always give green because they're afraid about the aflatoxin.
Okay. This thing I need to study. I've never heard about aflatoxin.
In Brazil, people, it's not common.
I'm sure aflatoxin has to do also with manure.
Okay.
Has to do with manure also.
A manure also.
I need to check. Let's talk about the NDF. It's I usually call it the total fiber. Well, fibers, the green part of the plant, of the corn plant, they are important to keep the rumination active. If the food of the cow doesn't have fibers, the bacteria from its rumen will die. And when it happens, generally the cow suffers from acidosis. Okay, so the target on the total fiber in a good silage, it's around 35%. So 35% of the sample must be made of green part, let's say.
Of the?
Of a sample of silage. Something around 35% could be fiber. Okay. These values are calculated by a lab. It's not visually, oh, this has more fiber than this one. It's a lab that tells us how much percent a sample have on fibers, for example. So that's why for us, when we test our machines, it's important to having a lab with confidence that we can send a sample and they tell you, oh, this is a good one or this is not a good one. Okay. Good silage have from 38 to 45%. It's not a real problem. So if the corn dries, the MDF of the plant increase, so the quantity of fiber on the plant will increase. But because what we are talking here is it's a relationship between the green part and the yellow part, let's say, the kernels, the
Grains.
the spiga, como seria?
The cob.
Okay. So in the same plate, in the same plant, we have the cob, the ear, and we have the green part. Okay. That's let's say a proportion that we have from fiber, the green part, and the cob, the yellow part. So when the corn plant grows, the fiber will increase, but the grain, the ear, the cob, it will increase too. So generally speaking, the relationship of these values, they will not change. Both of them are increasing. The digestibility will decrease.
You mean if the plant is 1 kg, the complete full plant is 1 kg, the fiber is the plant.
Fiber is the
Fiber is the plant.
Yeah.
And what would be the weight of the cob? Like in India, like generally they say 300 grams is the cob weight and 1 kg is the complete plant weight. That means 700 grams is a plant weight.
Yeah, no, what I'm talking here is that the cow needs fiber and cob, okay?
Yeah.
But in a certain proportion. The cow, you cannot send only fiber to the cow,
Yeah.
and you cannot send only cob to the cow. You need a
Balance.
Yeah,
Complete balance.
between them. This is the balance would be around 35 to, let's say, 40% fiber and 34% starch. So it's a balance between the cob and the green part. Okay, but the NDF, it's total. It's a total quantity of fiber that the plant has, and not all of it. It's digestible for the animal. Okay. Oops, here, just forgot. The ADF, it's what I call the bad fiber. Bad fiber because it is this one. It's not digestible by the cow. Okay, so this is a thing that we don't like to have on our silage. The target would be values below 20%, but we commonly found values from 22 up to 30%. These fibers are not digestible by the animal. Okay, mostly of them we call the lignin. Lignin is what gives the stiffness to the stalk. So here, as you can see, the lignin is the white things that you see in this picture. So a lot of seed developers, the seed companies, yeah, they are developing, for example, a stalk that is bigger, but with less lignin on it. This will be good because lignin is important to the milk, to the corn plant. Because if you took off all the lignin of it, the plant will fall down. So lignin is
Or
important.
even with the very low wind, it can fall down. This is a problem that these new varieties, sometimes it's not stiff enough that just with a normal wind it might fall down.
Okay.
It's just like the bones for the human body. The bones gives us the stability for us for becoming our feet, let's say. If you took off the bones, we would, but so that's why we
That's
cannot.
a good comparison.
Yeah,
Lignin is like the bones for the plant.
yeah. As I'm not an agronomy, I'm just curious. I can talk this kind of things, you know. But so the companies, they are developing bigger stalks with low lignin. So if they are big, probably they will have a little more stability to the corn stalk compared to this one, for example. But they are developing. It's not some countries have. USA have a lot of these, but in Brazil, for example, we didn't reach this one. But the idea is on having lower values of lignin in the plant because the animal will not cannot
Digest
it.
Yeah.
And
It's more harder. It's most harder part.
Yeah, it's the most harder part of the plant.
It's a cell. It's a cell.
Yeah, it's a
cell, right? It's a cell that cannot be digested, broken. into smaller things to be digested. And
Sometime we have seen when we chop, most of the parts we cannot chop. It's very hard.
No, for the chopper, for the harvester, I don't think
it will chop.
it will chop, but the problem is that the animal cannot digest it. Okay, and the most part of the lignin is located closer to the ground. Okay, that's why it has the stability of the stalk. So if it's located closer to the ground, some people are harvesting very high higher from the ground in order to took the lignin in the ground and not in the silo. Okay?
What is the ideal height to cut from the ground level?
People say generally about half a meter.
Half a meter.
Half a meter.
Half a meter.
For
Half a meter,
50 centimeters,
half
for
a meter
example.
would be something like 1.5 feet.
That is recommended.
There's not, I think, on your previous slide,
Yeah.
there was one thing saying there. You will get, if you cut higher, you will get better quality silage, but less production.
Yeah, sure. Because think with me.
But what happens sometimes the commercial silage prepare they cut from lower just to get more and more of weight.
If look, if I'm a producer and let's say I have a lot of animals, I have low silage production, then in this case I would harvest
From
the
the
lower
lower.
as I can.
Because we don't care about the people.
Yeah.
The dairy farmers, we don't care.
Quality. You need
I
quantity,
I need,
Yeah.
I
quality.
need food for my cows.
Yeah.
If I need a lot of food, then I would harvest maybe inside the ground, let's say. But just kind of.
In another case, if you have enough food, if you have cows with big genetical potential, if you want really good quality silage, then you can cut higher.
Higher. The higher is the
There is
best.
not a correct way.
No, there is not a correct way. I would prefer it on sending bad quality food for my cows instead of
No
food
No
for
food.
them.
But if you have excess
yeah,
silage, then maybe you can cut a little bit.
On top.
on the top, yeah.
Your productivity
So,
per
but even in Brazil, people don't cut by 1.5 feet top.
There
in
are
some
people-
places,
In
yes.
some places, yeah.
The people cut.
Yeah,
Yeah, in some places you can cut
yeah. Depending
actually
on
very high.
yeah. Because they know that the bottom part of the plant has a lot of lignin, so they prefer to send it on the ground.
Okay, they make it manure.
It's organical for the ground.
Organic
so-
for the ground.
Yeah, so this is good.
Here in Brazil, no-till agriculture, it's very, very common.
Yeah.
So the more straw or residues you leave on the ground, you will keep moisture and you'll have, you don't need to till or to prepare the soil again year after year.
Okay.
You will prepare every 4 years, 3, 4, 5 years. You don't need to prepare the soil every year.
Okay.
So here's a study made in the US when comparing a low cut of 17 centimeters from the ground and a high cut half a meter from the ground. So as you can see, the dry matter changed a little bit because you have, imagine that you are living in the ground, the green part, so there's more dry part on it. So that's why the
It's
dry
closer
matter
up to,
increases.
it's closer to the sun, it dries, it starts drying from up.
From down to, yeah, that's it. The crude protein didn't change from 7 to 7.1, so didn't change. But take a look on it. This is the bad fiber. This is the non-digestible fiber. It lowers from 24 to 21.8.
It's a big difference.
big difference. Yeah, and the total fiber didn't change too much. I mean, of course, you have less total fiber, but the most different stand on the ground. So you have less fiber but better fiber. Okay. The quantity of starch increase because in the same proportion you have less and more carbs than fiber. That's why the quantity of starch increased from 30 to 35. And but take a look on this two lines in here. Yeah, this one. The production in tons per hectare. I mean weight per area. You have less because you recollected less tons per hectare. So here we reduced it 12%, but the production in tons of dry matter per hectare only less 7.4%. But take a look at this. The estimated milk, it's let's say it's a value that compares. We'll talk this later, but it's a sheet developed by the Wisconsin University. When you put some values on it from KPS, from dry matter, FDN, NDF, a lot of things, and they give an estimated quantity of milk that a cow would produce if the cow ate that sample. Okay, it increased more than 5% because the quality of the silage is much better. So comparing, should I need to cut low or cut height? If I have enough food, then I would cut height. If I need this food for my animals, then I would.
You mean the best quality milk producer just cut on the higher side, they get the better milk quality?
That's it.
So this is a recent study or this is an old study?
No, this is a U.S. study, and we've we've made this here in Brazil by making some harvesting low and harvesting up, and we've get the same results. Okay. So just a summary. We have a concept of effective fiber. The corn silage should have fibers long enough to optimize the rumination, but small enough in order to get a good packing and to avoid segregation in the fruit. I mean, if you have a long fiber just like this, it's good for the animal because it will stand on its rumen and it will stimulate the rumination. Okay.
It will stretch.
Yeah, but if it's long enough, the cow won't eat it. So it's not good. You need to have small enough and good enough and big enough.
Somebody prefer like the dry like hay. Hay should be big and silage should be small.
Yeah, but even the green part that, okay, it should be big, it cannot be too big. Because a lot of producers, or a lot of machinery producers, you can harvest with my self-propelled machine for almost 40 millimeters. 40 millimeters,
it's
40 millimeters around 1.5 inches.
Yeah.
1.5 inches.
It's too high.
So we supplied some C120 stationery in India, and their veterinary doctors say that you need to cut more than 1 inches.
It depends on the total diet.
Yeah.
Yeah.
If you cut too long, your kernel processing will decrease.
Yeah, it will.
So what we have taught, you should cut smaller, the corn silage, and the hay you can cut longer. Because the hay you don't need to break anything. So the hay will be the roughage factor.
Scratch factor.
Scratch factor.
Yeah.
Okay.
But we'll see later how many millimeters.
If you are giving only corn silage, maybe you want to go a little bit longer.
Bigger.
Yeah, yeah.
But if you're giving hay or grass, chopped grass, you can
Certainly, I
chop the
would
grass or
recommend-
the hay longer
Yeah.
and doing a finer chop in this for silage,
making.
you will have very good benefits of the cracking of kernel.
Yeah. The total digestible nutrient, it's just a count that ABC Foundation makes, but it's a consequence on the bed fibers. When this value of the non-digestible fibers is too big, the total digestible nutrients will go down. It's a consequence from the bed fibers, okay? But it's a value that they calculate. Starch, it's a carbohydrate stored in the plants. They are in the kernels, okay? They are present in the grains. So the more grains you have, the more amount of starch you have in your silo. It's directly associated with the animal's milk production. So the more starch you have, the more milk you will have later. And the target, our values are above 40%, but this is too difficult to reach actually. Only the top producers can reach these values, but generally we found values above only 25%. So that's why I was talking about, for example, the quality of the seed. It's impossible on having above 40% of starch in a bad seed. Okay, even if you have a bad seed, we will never reach this kind of values. So we will have a lower milk production rate. Okay. Oops. What I call granulometry, it's just as Rafael was saying before, it's the distribution of the particle size in the chopper. So as we told you, we need to have low particles, and we need to have big particles in silage. The small particles will be absorbed too fast, and the big ones will take more time in order to be absorbed. Is thinking that the kernel processor will recut everything that passes through the process. So as JF machines, as they don't have this post recutter, for example, if you use in JF machines something around 20 millimeters, no, you are in real problems. It's not good because you will have a lot of 20 millimeter size when the plant passes through the rotor. This is not good. That's why it's different from machine to machine. Okay, they tell to cut longer in order to save fuel, because the longer you cut, the less fuel consumption you will have. Okay, and it is the Achilles heel for the self-propelled machines.
At the end, the self-propelled machines, they say, okay, we'll cut on 19 or 20 or 30 millimeters. That's what they set on the rotor. After it goes through the processor, it will be maybe 10, 15 smaller particles.
Yeah.
But they use a little bit of this to promote the kernel processor.
Yeah.
Okay.
That, we can cut longer. But they cut longer on the rotor, but on the processor they reduce it again.
Yeah.
So they don't tell this.
Yeah. And in the US, they have those big stalks with less lignin that I showed you earlier. They call this kind of seed the BMR. It's a kind of seed that they have in America. We don't have yet here. It's here in Brazil. But these seed producers are recommending, cut longer, because you will take advantage of the fiber. And I sent an email with the guy that developed the pan-statical particle separator from the US. It's this guy here. and he sent me an email. He answered me, and he told me, I think that our recommendations are still good, the Penn State recommendations, and the agronomical engineering and the plant genetics people are not understanding the cow and her sorting, intake, etc. What I mean, cut longer, okay, but if the cows don't eat it, it's not effective fiber. It's effective on a computer, it's effective on the Excel sheet. Theoretically, but in practical, if the cow cannot eat it, it's not effective, okay? As you noted quite well. If it's better digestible fiber, then it's good. But it starts out as effective fiber. What he's calling effective fiber is the fiber that stimulates the rumen. And he tells us that a 4 millimeter fiber, it's already effective. So you don't need to cut in a, let's say, in half of a meter, because 4 millimeter is already effective. So you don't need to cut.
So it's better to put the like hay, bigger size hay and smaller size silage.
Yeah. As Raphael was telling.
It's a strategy.
Yeah, it's a strategy. If you have hay or grass, you could lower you could make shorten the chop size on the corn silage in order to get a great APS, but still then you need to add big fiber in order to get the rumination.
Rumen sketch.
And you can use grass or hay, etc. Okay. So that's why I told you, JF harvester achieved the recommended by Penn State when the cut is adjusted between 4 and 9 millimeters. Okay, but these values that may vary depending on the hybrid, the tractor, the ground conditions, the dry matter, etc. Okay, in the diet corrects what it's cut. Okay. This is just a classes making a marketing about the shreddage, their new kernel processor. But Penn State made some conclusion that the risk of unwanted fermentation in this case is not to it would increase. So they're not reaching good values by using this kind of processor. The pH is pH, yeah. Just forgot the letter H in English. Yeah. Here in Portuguese it's called H. It's pH. The pH is the hydrogenic potential. It's just a way on measuring if the silage is acid or not. Okay. The recommended values are close to 3.6%, but we found commonly here in Brazil values between
not percent, 3.6.
Yeah, sorry, yeah, 3.6. But we commonly found here in Brazil values up to 4.5. So, but it's above 4.5. Certainly, you will have dry silage, poor packing, exposure to oxygen, etc. So, a dry silage makes it much more difficult for the bacteria to act and to produce the lactic acid.
Okay.
So if you have less acetolactic, the pH will be bigger. Okay.
The faster you reach this pH, the better.
Better.
Mm-hmm.
That's why it's important to harvest fast, cover fast,
Yeah.
pack fast.
They recommend it in 1 day.
1 day the bunker
1
closing,
day.
16 hours, no?
But very difficult.
But in India, 1 day is like the bunkers are very difficult.
No, it's the theoretical people. I believe they would recommend short silos, but close it day to day.
Yeah.
So, for example, just a short silo produce on the entire day, and when the day is finished,
That's where the silage bagger
yeah.
improves
Yeah,
silage
yeah.
quality.
That
Sure.
because you are feeling the machine,
Yeah.
and what's inside there, besides that little face, it's already
Pack
packed
instantly.
and isolated from oxygen. Okay, so that's also the baler is also very good. The small bags, they are also very good for closing faster,
Yeah, yeah.
filling and closing faster the container. Okay.
The IVDDM is just the value that expresses the total amount of organic matter present in the corn silage that can be digested by the animal. Okay, so the higher the value, the higher the energy content of the silage. So the goal for this value is above 74, but values with just above 54 are found with easy here in Brazil.
Isso vai chegar mais ou menos na metade. Acho que dá um break.
Sim, eu vou ficar.
Não,